The state of Gujarat has set an example worth emulation when it comes to robust, world-class infrastructure. It is possible due to various factors such as political stability and policy-driven governance. Gujarat Industrial Development Corporation (GIDC) has been created to secure the orderly establishment and organization of industries and thus serve as the backbone for industrial development in the state. Desalination plant. Desalination uses reverse osmosis technology to separate water molecules from seawater. Water from the sea is forced through thousands of tiny wrapped semi-permeable membranes under very high pressure. The membranes allow the smaller water molecules to pass through, leaving salt and other impurities behind. Few years back, before the foundation of the desalination plant, the saline water of the estuary was of no use and land beside the estuary was barren. The desalination plant was established for productive use of the land and also enabled the scope to use saline water by converting it into fresh water. Now let us understand the process involved in the desalination plant. Initially, at the time of high tide or low tide, water will be raised into the reservoir from the Narmada River estuary through 4 perforated intake screens. Inside the intake screen, chlorination will occur with the help of a chlorine dosing system to prevent marine growth inside the intake system. From the river, water will move to the pump house through the 1800 DIA underground twin HDPE pipeline by gravity. In the pump house, water will enter the travelling band screen chamber through inlet chamber, where large unwanted particles inside the water will be eliminated by a continuously rotating screen. With the help of vertical turbine pumps, water will be pumped out from the pump house to the grit chamber. The function of a grit chamber is to slow down the flow of water so that relatively heavier particles like pebbles, stones will be separated from the water flow. From the grit chamber, water will move to the reservoir through the pipeline by means of gravity, where water will be stored for a day for natural sedimentation. Inside the reservoir, there will be different salinity levels in the water. High salinity due to high tide water and low salinity due to low tide water. The reservoir will maintain equilibrium between different salinity levels and will form homogeneous salinity in the water. After storing for a day, water will be moved to settled water tank via box channel. Water will be pumped out from the settled water tank to the flocculator. Before entering the flocculator, chemical dosing in static mixer will take place and chemicals will be added to water which will act as a coagulant and pH corrector. The role of flocculator is to reduce the turbidity of water with the help of flocculant and pervious dosed chemicals. The suspended particles will be attracted towards each other due to coagulation and flocculation, and it will be converted into heavy particles known as floc. The floc will settle down and sludge will be formed. The sludge will be disposed to the sludge tank. The filtered water from the flocculator will overflow and will move to the lamella water clarifier. In lamella water clarifier, there are in total 12 beds. Let us understand by taking a single bed. Water will enter from the bottom. It will start rising. It will start raising. And to increase the surface area of the tank, there are lamella plates fixed in a slant manner, due to which sedimentation will occur. Filtered water will move up and unwanted particles will be sedimented at the bottom. Sludge will be formed at the bottom by unwanted particles, and sludge will be moved to the sludge tank via pipeline. The water filtered in the lamella clarifier will overflow and will move to the gravity media filter via a channel. In the gravity media filter, there are in total 24 beds. gravity media filter uses gravity as the motive for a fluid stream to pass through a bed of granular media through which removal of impurities is achieved. The water from the channel will enter into the main header. From the main header, water will enter into each bed via service water inlet. The flow of the water will be distributed equally inside the bed via channel. Now, the water will flow from multiple media like anthracite, sand and gravel, where natural filtration will occur and impurities will be absorbed by the filter media and same will be removed by backwash. Below filtration medias, there are two outlet headers attached with PVC perforated laterals with 400 micron holes in it. Through laterals, filtered water will be moved out from the filtered water outlet header. In similar manner, water will be filtered in all the beds and will be collected into a canal via pipeline. From the canal, the filtered water will be stored in a filter water tank. The water used for backwash in the gravity media filter is stored in the brine water tank. The backwash water from the gravity media filter will be stored in the reject water tank and will be pumped out into the estuary. Now, the filtered water from the filtered water tank will be pumped out to the ultrafiltration building. Before entering into the ultrafiltration building, H2SO4 dosing will be done for pH correction. In the ultrafiltration building, there are a total of 22 skids which will undergo the ultrafiltration process to remove further suspended solids. The water will enter into the self-cleaning filter and will be moved out to the inlet header of ultrafiltration skids. Ultrafiltration UF is a variety of membrane filtration in which forces like pressure or concentration gradients lead to a separation through a semi-permeable membrane and will be filtered out from bottom to top and will be moved into the outlet header. From the outlet header, filtered water will move into the UF permeate water tank. Periodically, backwash will be done by UF permeate water and disposed to the reject water tank. Beside the ultrafiltration building, there is a bulk acid area. Bulk acid area is used to store acids which are used in preparation of chemicals used in chemical dosing. With the help of a pump, chemicals will be transferred to the chemical house. In the chemical house, there are 4 FRP tanks and polyelectrolyte concrete RCC tank. With the help of the first 2 FRP tanks, ferric chloride dosing will be done at the flocculator. And with the help of other 2 FRP tanks, chemical dosing will be done to water entering the ultrafiltration building. With the help of RCC tank, chemical dosing will be done to water in individual pipelines at flocculator. From the ultrafiltration permeate water tank, the water will be pumped out to the RO building to remove dissolved solids. In the RO building, 2 types of reverse osmosis processes will take place: seawater reverse osmosis, brackish water reverse osmosis. First of all, the seawater reverse osmosis process will occur. The water will enter into the SWRO cartridge filter to undergo a self-filtration process. After filtration, water will move with high pressure into the inlet of RO skid with the help of a high pressure pump. The reverse osmosis process will occur in RO skid. The reject water will be released out of the RO skid with the high pressure. Such high pressure can be utilized to recover the energy of the system. To fulfill that purpose, the reject water can be used to recover the energy and enhance the pressure of service water with the help of an energy recovery device. The service water from the inlet header will enter into the energy recovery device with low pressure. The reject water of the reverse osmosis pressure will flow through the back of the device. The pressure exchanger will transfer the high pressure of reject water to the feed water. As a result, the pressure of feed water will increase and the pressure of reject water will decrease. Booster pump is provided to maintain the pressure loss from pressure exchanger. The service water with the help of a high pressure pump will move into the inlet of RO skid and the reject water with low pressure will be disposed back to the brine water tank. After the desalination process, if permeate water has not achieved the criteria of product water, then the water will move to the SWRO permeate water tank. Otherwise, the water will be stored into the final product water tank. Now, from the SWRO permeate water tank, water will further undergo the brackish water reverse osmosis process. The water will flow into the BWRO cartridge filter to undergo natural filtration. After filtration, water will enter into the inlet of BWRO skid and reverse osmosis process will take place. BWRO is a two-pass RO process. The water rejected from the first pass will be used as an inlet to the second pass, and water will be filtered through the RO process again. The reject water from BWRO will be recycled to the SWRO cartridge filter header, and the permeate water will be collected in the final product tank. The water from the product tank will be used by the industry as fresh water. In this way, the saline water is converted into fresh water by the desalination plant and further used by industry and for household use.